Nuestra próxima sesión nos llevará al mundo de las innovaciones tecnológicas y también al almacenamiento y transporte de GNL. El señor Aziz Bamik, gerente general de GTT Norteamérica, nos presentará las soluciones innovadoras que GTT está desarrollando para optimizar operaciones globales de GNL. Bienvenido.
Buenas tardes, delegados distinguidos. Es un honor y privilegio apoyarme ante usted. Gracias a Kena por invitarme nuevamente después del exitoso evento del año pasado en Cartagena. Last year, I was pleased to introduce the subject of onshore. This year, I'm going to take you offshore, and I'm going to discuss about innovations in the FLNG segment. Okay. Agenda. First of all, some market outlook. This is just a snapshot of the different projects in which we've been involved. FLNG is not new. It has been around for many, many years, but it became really a reality after a lot of work. And the first project in which we as GTT we've been involved is Puteri FLNG, Satu, where we collaborated with our good friends from Technip Energy, but they are in the room. So if you have any questions, go and see them. As far as GTT is concerned, we have been in the LNG business for 60 plus years. We were born with the birth of LNG. We provide technology, innovation that are critical for the storage and transportation of liquefied natural gas. And beyond that, cryogenic gases, in fact. As we speak, there are about 550 LNG carriers equipped with our technology that are in service, and there are about 340 that are under construction. This number is not up to date. So that means that in the next 4 years, we are going to build more than half of the existing LNG carrier fleet, which has taken us more than 4 decades to build. So it's quite impressive for the LNG business. As far as floating is concerned, there are about 40 FSRUs that are equipped with our technology, and 4 FLNGs that are in operation, and 2 on order. My today's topic is going to focus on the 4 under construction, in service, and the 2 on order. You have also other type of technology, prismatic type B. They don't have a lot of references, but just for sake of, I would say, fairness, I put them there as well. So this is a map of all existing FSRUs / FLNGs worldwide. I'm not going to go throughout all of them. My point is just as a company critical for providing these technologies, everything you are going to see is now based on the return of experience and knowledge we learned and gained throughout the years in helping the operations, the construction, the design, the construction, and operations of those assets. And they are all over the world. Starting by the first unit, these are very few figures that are important. First one, as I said earlier, in operation since 2016, offshore Malaysia, it's the FLNG Satu by our friend Petronas. Technip Energies and Hanwha Ocean collaborated into this project. It's a relatively small asset, relatively, it's 1.2 MTPA. With about 177,000 cubic meter storage capacity, and it features our technology called NO96. I'm going to go through it quickly. This is another one, Shell Prelude. This is a gigantic asset. It also has been, I would say, designed and procured and built by Technip Energy / Samsung, the Korean shipyard, 3.6 million tons per annum for LNG capacity. And she has also LPGs as well as condensate capacity. As far as storage is concerned, it's 220,000 cubic meter of storage. for LNG and 90,000 cubic meter of storage for LPG, which is quite good, quite big. In terms of overall length, you can picture this asset like 4 soccer fields length, which is huge. It has our so-called Mark III technology. It's been in operation since 2018. Another one, the DUA, which is the second FLNG for our friends Petronas, also in consortium between GGC and Samsung, 1.5 MTPA, about same capacity as Satu, 177,000 cubic meter, featuring Mark III technology. She is in operation since 2020. Coral, she is one of the last one in operation, also being designed, procured, and built with Technip Energy, GGC, and Samsung. 3 million tons per annum. Location-wise is offshore Mozambique. First asset to monetize the gas production in Mozambique. Almost 240,000 cubic meter of LNG storage capacity. And she's been in operation since 2021. I think, Sergio, you touched base on that earlier. Our good friends NFE finally commissioned the Fast LNG project, FLNG. It's a very brand new concept with jack-up rigs. On top of them, you have the liquefactions, and coupled with that, an FSU. The FSU is an old LNG carrier that has been retrofitted in FSU, so it acts as the storage. It has a capacity of about 160,000 cubic meter. I will come back onto how you transform a trading LNG carrier to be able to stay on site for more than 10 years. It looks easy, but it's not so easy, because this type of asset needs to go to dry dock normally every 5 years. And she was an old lady, so we've been working hard in order to qualify her to be able to stay offshore, and I will explain to you how we did that. There are other things that are currently under construction. Petronas has a third FLNG under construction, about 2 million tons per annum, 200,000 cubic meter capacity. She will feature a design that is very peculiar and very innovative. I will talk about it later. And she should be in operation in 2026, 2027. Cedar FLNG, this is an EPC contract that started this year. Black & Veatch, for the top side, Samsung as an EPC contractor. 3.3 MTPA, first ever FLNG, West Coast Canada. So we are really looking forward to it. It will be in operation in 2027. It features also our technology Mark III Flex for the first time. It's a near shore, it's not offshore, deep sea water. So a very nice design where we can accommodate all our innovation. There is another one, Delphine, that is going on right now. This is for US, Gulf Coast. It's up to 4 million tons per annum, 200,000 cubic meter of storage capacity. Right now it is in permitting process, but they have been a feed and they are now doing some feed optimization. There are several units that will take feed gas from the United States pipeline and feed this unit. So unlike Puteri, Satu, Prelude, and all these projects, when you take from the ground the gas and you process it, you liquefy it and you store it, here you take a processed gas pipeline, you liquefy it, and you make it accessible for the market. There is another project, KIMS, I'm not going to go through it. It's another one near shore in Canada. YPF, the reason why I'm focusing on this one is, I'm going to stay a bit on this one, is going to be, if materialized, the largest FLNG export facility in the Americas. Is going to feature up to 5 MTPA. LNG storage capacity is still undetermined, but I can tell you it will be quite huge. It just has been repositioned. Public knowledge information, there is a tender going on right now, and we should soon hear about this project that should be FID next year. So it's going to be a quite important milestone for South America and for YPF and Argentina in particular, because this is a phase 1 of a project that can go up to 20 million tons with a phase 2 or 3 that could be potentially onshore. facility, but the intention is to start by an FLNG, is to monetize vacuum water. So I'm going to talk to you. Earlier, you saw all the experience, all the projects, and what's the next steps, what's going to be new, and what kind of ideas we are working on within GTT. So first of all, to make it clear, we don't do everything on the FLNG. This is a typical scheme of with the responsibility matrix, who does what. It's quite complicated, but GTT, as far as we are concerned, we basically focus on all area that is in blue. Cargo tanks, hull, interface with pipeline on the deck, and all the top side is being done by people like Technip Energy and their partners. But us, and then all the upstream is being done by the operator usually. Us, we focus on the hull and the containment system. That does not mean it's something small, but it's good enough for our expertise. So the reason why I'm saying that is that unlike a trading vessel that is trading either full or empty, an FLNG platform is subject to weather constraints if it is offshore. She has to stay there for 25 years. An LNG asset, every 5 years, you take her to dry dock. And you can do maintenance and so on. You can do that on an FLNG. FLNG, she stay on site. If it is 300 kilometers off the coast, you have to be able to develop a maintenance strategy that will allow you to maintain the vessel and maintain the production. So what you have to do is to make sure that not to jeopardize the total production, and you have to develop strategies that will allow you to intervene and do maintenance in one tank while the others are in production. So this is a completely different approach. So of course, when we look at that from a design standpoint, there are many aspects that can affect the design from a GTT standpoint. First one is the total capacity of a unit. It's the draft. We have to define the best tank geometry that will accommodate the storage capacity required. And we have to take care of the elements. We cannot change the elements. If you have, during 25 years, what we call the 1,000 year peak storm, you have to consider it into your design. You have to take care of that and take that into consideration for your fatigue analysis and so on. And of course, everything about the surrounding of the vessel that we call the mooring system and so on, we have to take care of that. So when you took all these elements, we will put them into consideration and we will derive the best, I would say, tank configuration to meet the requirements. So one thing that is very important when we talk about these projects, it's the sloshing. Sloshing is it's a word that we throw out there. It is basically the movement of the liquid inside the tank. The problem is when you have a vessel that is at sea and you have a liquid inside this vessel moving, it can enter in resonance with the movement of the vessel. What can happen when there is this coincidence in resonance, you have huge impact on your containment system and you had huge impact on your hull. You want to avoid that, or at least you want to be able to manage those extreme situations. This is what we call the sloshing. These are very highly sophisticated hydrodynamic subjects. These are not easy because we are talking about LNG, it's not water. LNG at minus 163 degrees Celsius, and you have to conceive your design of a tank that is capable to withstand all these heavy loads. And we are talking about loads that can go as high as 80 bar. It's a lot. So in order to develop that, we develop all process. We have a huge R&D facility that is a combination of computation, hard physics and hydrodynamics, as well as tests. We will basically take, you can see on the top picture, a scale model of a tank. We will subject the scale model of a tank to all sea conditions throughout the life cycle. We will perform tests at various levels, liquid. We will even simulate the density ratio that you will find in an LNG tank by doing a gas mixture on top of it, and we will put 400 of sensors around the tank. And we will check that for months, 24/7. And we will be able to determine what is the pressure profile onto these tanks. So I save you this, but this is the process. How come we come to a design that is appropriate for the design for the operations? So all the experience that we gained through the years, we know how these assets are now reacting in real life, and we are able to optimize them. So as we speak, we are working on optimization by reducing the number of tanks. Because if you reduce the number of tanks, you reduce the number of equipment, and you save capex, and you improve the operations. We are currently going from 4 pair of tanks to 3 pair of tanks on certain design. Whenever your asset is being operated in mild condition, we can even do 3 tanks, 4 tanks instead of 6 or 8. That means that you save a number of pumps, you save the piping going in and out, and so on. All those aspects are very important to simplify the operation. And this is what we are doing now, and this is what we are applying on some of these projects, like the CEDAR one is going to be 1 tank, 1 row configuration because it's sitting alongside a dock. There are things that I wanted to focus on as far as FLNG is concerned on my last part, is how you convert an asset that has been trading as a conventional LNG carrier into an asset that is going to sit offshore for 10 years. So we have a whole process to convert trading LNG carriers to FSU. I talked about the NFE Fast LNG in Altamira in Mexico. We've done a lot of work in order to be able to qualify the vessel suitable for the offshore conditions in Altamira. And one thing we came up with in this project is we developed a process whereby she can receive vessels, and this is very important, ship-to-ship transfer. You want to optimize the operating window because there are certain weather conditions where you don't want 2 vessels to do a transfer. So we are developing processes in order to safely operate these ship-to-ship transfers, to optimize them by doing boil-off gas management studies. I'm looking at Jürgen, who knows that very well from Höegh LNG. It's very important to streamline the flow, to manage the boil-off gas, and also optimize through hydraulic studies the flow rate when you transfer this commodity. And one thing that is very important is to increase the safety. We are now able to develop tools that will allow you to look at the weather forecast in the next 72 hours. And you will have on board, and you can look at that on your app, on your mobile phone, your iPad from your couch. You can look at the weather forecast. You can estimate the best window to operate a ship-to-ship transfer. Because basically, these weather forecasts are going through a machine learning algorithm to tap onto the database for sloshing, and will tell you when it is red, when it is green, when it is orange, in order to perform the ship-to-ship transfer. Basically, is to help the crew have access to these advanced tools in order to safely anticipate the operation. These are the things that are being implemented, for example, on Penguin in Altamira. The other things that are implemented in Altamira is that she is classified as a vessel. Every 5 years, she has to disconnect and go to dry dock. But when the owner contacted us, they asked us, is it possible for her to stay there for 10 years and not have to go to dry dock? So we developed what we called an alternative survey program, which is basically a program that will allow you to go to the flag and ask for a waiver in order to be able to keep the vessel on site and not have to go as per regulation into a dry dock. Because remember, when you go to dry dock, you have to gas free the vessel. It costs you a lot of money, it takes a lot of time, and while you are doing that, you have to replace in order to ensure continuous operation. So you can imagine how this kind of engineering services and new innovation are very important for the commercialization and optimization of the return of investment on your asset. So we developed this program, and as we speak, we are submitting that to the flag, and we hope we will get approval from flag to qualify this vessel to stay there for 10 years without having to go to dry dock and to ensure continuous operation on site. So this is very, very important. And to do that, we look at the forecast, the scatter diagram, the weather conditions. We look at past life of the vessel, and we do also forecast on the future life of the vessel, and we project what we call the fatigue damage, and we are able to say at any given time, based upon what the vessel she's seeing throughout now all the algorithm that we have at our disposal, in order to say what is the projected fatigue life. And go to the administration and say, I haven't hit yet my design criteria, I can continue to operate this asset safely. And last and not least, one thing that is very important for offshore, for FLNG platforms, and is being considered for Prelude, is being considered for Petronas, all FLNGs, and as well as Coral. As I said earlier, these assets are going to stay there for 25 years. They do not disconnect. So you have to assess that. And you have to be able to develop a risk-based inspection approach whereby you can open one tank while the others are in production. And you have to have also a maintenance strategy that will allow you to have spare parts in certain area, not very far from the production center. So as an engineering company, it was an interesting place to be for us because we decided, you know, when you talk to Shell, for example, on board Prelude, you have 250 different contractors. You can imagine they don't want to mess with many contractors for the tank. So what we decided to do, we decided to be a one-stop shop solution that will manage all the maintenance strategy on their behalf. Managing the spare parts in a warehouse close by, and also putting in place with a risk-based approach inspection program, putting in place a program that will allow us to safely maintain the operation, inspect one tank at a time while the others are in operation. So these are things that we are doing that are completely different from what we do on regular LNG carriers. I will be happy to take any question from your side, just some key takeaways on the technologies. As you can see, it's an unparalleled track record in the offshore industry. We have now new innovations that help improve the cost and the CapEx as well as the OpEx. And of course, we've been in this industry for 60 years plus now. We tend to be a long-term partner, so we will not disappear after the asset, as you can see, has been delivered, because we are supporting the operations and making sure that throughout the life cycle, it remains safe and reliable. With that, I leave you and looking forward to any questions during the break, and I thank you for your attention. Thank you.